Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.78. While solving this problem, we will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always equal to the product of current through that resistance and the value of resistance itself. We also will be using parallel equivalent resistance calculation formula. R equivalent of three parallel connected resistances is calculated using this equation. Now move towards the problem. Exercise problem number 2.78. Find voltage VAB and current I1 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of current I1 through this branch and voltage across these 2 points labeled as VAB. So without wasting time, let's proceed towards the solution. In order to calculate voltage across these points, we should have the values of voltage across these individual resistances. And for the calculation of voltage across these resistances, we should have the value of current through these resistances. Right now, no current is specified inside this network. So first of all, we will simplify this network to calculate total supplied current. Then using that total supplied current, individual branch currents will be calculated. And these branch currents will be utilized for the calculation of voltage across these individual resistances. So first of all, we will simplify this network to calculate total supplied current. For that purpose, we will start from left hand side of the network. These three resistances are connected in parallel connection. In order to simplify the network, we will find their equivalent resistance and replace these resistances with that equivalent resistance. Equation for the calculation of their equivalent resistance will be R equivalent is equal to R1 multiplied by R2 multiplied by R3 divided by product of R1 and R2 plus R2 and R3 plus R3 and R1. In this case, R1 will be 12 kilo ohm, R2 will be 6 kilo ohm and R3 will be 4 kilo ohm. Place values inside the equation and solve this equation to calculate R equivalent of these three parallel connected resistances, that will be 2 kilo ohm. We can replace these three resistances with a single resistance having the value of 2 kilo ohm. Now these two resistances are converted into series connection. We can find their equivalent resistance, that will be the sum of both resistances. In this case, it will be 10 kilo ohm. Similarly, these two resistances are also connected in series connection. Their equivalent resistance will also be 10 kilo ohm. Modify the circuit by replacing these two resistances and these two resistances with 10 kilo ohms. Now these two resistances are converted into parallel connection and both have same values. Their equivalent resistance will be calculated by dividing the value of a single resistance with the number of resistances. In this case, it will be 10k divided by 2. R equivalent of these two resistances will be 5 kilo ohm. Modify the circuit by replacing these two resistances with a single resistance having the value of 5 kilo ohm. These two resistances are converted into series connection. Their equivalent resistance will be equal to 10 kilo ohm. Modify the circuit by replacing these resistances with a single resistance having the value of 10 kilo ohm. Again, these two resistances are converted into parallel connection and both have same value of 10 kilo ohm. Their equivalent resistance will be 5 kilo ohm as we have calculated in previous step. So we can modify the circuit by replacing these two resistances with a single resistance having the value of 5 kilo ohm. Circuit is simplified. Now we can calculate current through this network. We have a voltage source connected across 8 kilo ohm resistance. So the current through this network will be 40 volt divided by 8 kilo ohm. Value of current will be 5 milliampere. We have calculated total supplied current. Now we will expand network towards the original form so that we can calculate individual branch currents. This 5 kilo ohm resistance was the equivalent resistance of two 10 kilo ohm connected in parallel connection. So we will replace this 5 kilo ohm resistance with two 10 kilo ohm resistances connected in parallel connection. In this network, I have made a mistake. The direction of current was upward, but I have taken it downward. So you have to make correction here. The direction of current will be upward. Now we have to find current through these branches. This 5 milliampere current is entering on this node in this direction, and it will distribute among these two branches. Because both branches have same resistance, so this 5 milliampere will divide equally in both branches. So current through these branches will be equal to 2.5 milliampere each, and the direction of current through these branches will be downward. Now further expand the network. This 10 kilo ohm was the equivalent resistance of two resistances connected in series connection having the values of 2 kilo ohm and 8 kilo ohm. Similarly, this 10 kilo ohm was the equivalent resistance of two 5 kilo ohm resistances connected in series connection. Modify the network. This 10 kilo ohm resistance is replaced with two 5 kilo ohm resistances connected in series connection. Similarly, this 10 kilo ohm resistance is replaced with 2 kilo ohm and 8 kilo ohm connected in series connection. Now current through this 8 kilo ohm resistance will be same 2.5 milliampere because of series connection, and the direction of current will be this direction. Similarly, current through this 5 kilo ohm resistance will be same 2.5 milliampere, and the direction of current will be clockwise direction. Now this 5 kilo ohm resistance was the combination of two parallel connected resistances of 10 kilo ohm. So we will modify the network by replacing this single 5 kilo ohm resistance with two 10 kilo ohm resistances connected in parallel connection. Again, the directions of current will be clockwise direction. In this branch also clockwise direction, and through this branch will be upward. Now we will find current through these branches. In this case, the total supplied current is 2.5 milliampere, and it will distribute equally among both branches because both have same resistances. So the value of current through this branch as well as this branch will be 1.25 milliampere. Again, the direction of current through this branch will be clockwise direction. This 10 kilo ohm resistance was the combination of 4 kilo ohm and 6 kilo ohm connected in series connection. So we can replace this single resistance with two series connected resistances having the values of 4 kilo ohm and 6 kilo ohm. Modify the circuit. 10 kilo ohm resistance is replaced with 6 kilo ohm and 4 kilo ohm. Currents through all these branches is calculated. Now we will expand the network from left hand side to calculate remaining branch currents. If we remember, this 2 kilo ohm was the combination of three parallel connected resistances having the values of 12k, 6k and 4k. So we will modify the network by replacing this 2 kilo ohm resistance with three parallel connected resistances. This 2 kilo ohm resistance is replaced with three parallel connected resistances. Now we will try to find current through this branch because it is equal to I1, and we have to find the value of current I1. For that purpose, we will find the equivalent resistance of these two parallel connected resistances. Their equivalent resistance will be equal to the product of both resistances dividing by their sum. Product of 12k and 6k will become 72k square, divided by 12k plus 6k it will become 18k. 72k square divided by 18k will answer 4k. So we can replace these two parallel connected resistances with a single resistance having the value of 4 kilo ohm. Here is the updated circuit diagram. 12k and 6k is replaced with 4 kilo ohm. Now we will calculate current through this branch, that will be equal to I1. Total current that is coming on this node is 2.5 milliampere and it is distributing among these two branches. Because both branches have same value of resistance, so current will equally divide through these branches. So the value of current through this branch will be 1.25 milliampere and the direction of current will be counterclockwise. And this current will be equal to I1 because of same branch. So the value of I1 will be minus 1.25 milliampere. Here minus sign along with the value of I1 is indicating that the direction of current I1 inside this branch is taken wrong direction. The actual direction of current is opposite to the direction of I1. We have calculated the value of current I1. Current through these all branches is also calculated. Now we will calculate voltage across these resistances in order to calculate VAB. We will start from this 4 kilo ohm resistance. Current through this resistance is 1.25 milliampere and the value of resistance is 4 kilo ohm. So their product will be equal to voltage across this 4 kilo ohm resistance, that will be 5 volt. Similarly, current through this 5 kilo ohm resistance is 2.5 milliampere and value of resistance is 5k. So voltage across this resistance will be 12.5 volt. Voltage of this 8 kilo ohm resistance will be the product of current through it 2.5 milliampere and the value of resistance 8 kilo ohm. Their product will be 20 volt. So 20 volt will be appearing across this 8 kilo ohm resistance. We have calculated voltage across these individual resistances. Modify the original circuit along with calculated voltage with their polarities. In this figure, these polarity notations with red color are wrong because it was taken according to the wrong direction of current. Right polarities of voltage in this figure is in blue color. We will apply KVL in this semi-closed loop to calculate voltage VAB. For that purpose, we will assume the direction of current in counterclockwise. KVL equation for this semi-closed loop will be start from this 4 kilo ohm resistance. Current entering terminal is positive, so 5 volt will be taken with positive sign. Next, voltage across 5 kilo ohm resistance will be taken with positive sign because current entering terminal is positive. And the voltage across 8 kilo ohm resistance will be taken with negative sign because current entering terminal is negative. Voltage VAB will also be taken with negative sign because current is entering from negative terminal. Add these values together. It will become minus 2.5 volt minus VAB equal to 0. Place minus VAB on the other hand side of equal to calculate its value, that will become minus 2.5 volt. So the value of current I1 inside this network is minus 1.25 milliampere and VAB is minus 2.5 volt. This was exercise problem number 2.78. Thank you. See you again in next video.